Hello, this is Mrs. Landak. We're going to discuss vertical angles and special angles in this presentation. The first step here is taking a look at vertical angles. And those vertical angles just share a common vertex. The red angles here, if I outline them in red and green here, they do not share a common side. The only thing that they share is the vertex. This angle here, I squiggle it, and the squiggle here. The squiggled angle is a vertical angle with that red degree measure, and this green one here is a vertical angle, and they're opposite each other such that X marks the spot. The blue angles as well are vertical angles, and we learned that vertical angles have the same measure. Here we look at supplementary angles, which states that two angles that add up to 180 are supplementary angles. This is called a linear pair when they are adjacent. And here they are non-adjacent. In both cases, the measure of angle 3 plus the measure of angle 4 should equal 180. Either be a linear pair where they're adjacent or where they're non-adjacent, they should equal 180. Here we're looking down below as complementary angles. And complementary angles are any two angles that sum to 90. In both cases, on the top case, they're showing you adjacent angles, and there are actually right angles up with their little box in here. That would indicate that the measure of angle A plus the measure of angle B should equal 90. If we look down below, we can see that A and B are now non-adjacent, and they still add up to 90 degrees. So the types of angles we're looking at are vertical angles, which are across from each other, such that the X marks the spot. They are equal in measures. We're looking at supplementary angles, two angles that sum to 180. And we're looking at complementary angles, two angles that add up to 90. And as I erase this, we're going to go into the next screen. We're going to look at this vertical angle right here. And when we look at these vertical angles here, we can see X marks the spot. Again, if I make angle 1 in green and I make angle 3 in blue, you can see their non-adjacent sides form opposite rays. And angle 1 is equal to angle 3, so we can mark that as the equal arc. So the measure of angle 1 equals the measure of angle 3, which means angle 1 is congruent to angle 3. The same logic here with angle 2 and 3. Their non-common sides do form opposite rays. And so we can say the measure of angle 4 is equal to the measure of angle 2, which means angle 4 is congruent to angle 2. Those are vertical angles. They only share their vertex. And the next slide we're going to look at, I get better at erasing this, folks. I'm trying. Well, we're just going to have to do it this way. It looks like I'm trying my circles. I'll have to take the time. You just have to be patient with me. Thought I could just circle this whole thing around and hit it in the center, but it's not working that way. So we'll slowly erase my marks that I have here. And we will go on to the next slide. And if we look here on this is displaying again vertical angles. We can see that the red angles are each 46. They are congruent to each other. X marks the spot. You can go right here. X marks the spot, which means that we have straight lines, and they are across from each other. They're also displaying that they are equal in measure. But that was the trick in erasing, but we'll find out. Maybe I can get this little here. All right, sorry about that, folks. But here we have another example. They are vertical angles, and so that tells us they are equal. So we can set 74 equal to 2x degrees because we know that they are equal. They are vertical angles. We divide by 2. And when we divide by 2, we find that x equals 37 degrees. And so if I were to put 37 back into 2 times 37, I do get indeed 74 degrees. Vertical angles. And again, I'm not doing very good in this erasing part. I'm trying. It seems like this little circle. Something that must be off. I must have to learn about that in the future. Okay, the next one is supplementary angles. And we can see here we have two cases. These are non-adjacent. And we can see that if we add 130 plus 50, we do indeed get 180. These are adjacent. I put ADJ for abbreviation. And if I add 110 plus 70, I do get 180. So we have two angles that sum to 180 for supplementary angles. And we can see in this case that they're non-adjacent in the top, and they are, non-adjacent in the top picture, and they are adjacent in the bottom. And we also call this bottom one here a linear pair when they're adjacent. They get a special name. Here we have a linear pair, they're supplementary, and again I should know that they sum to 180. Why? Because this side and this other non-common side here form opposite rays which form a straight angle, which is 180. And so x plus 24 should equal 180. We subtract 24 from both sides and we get 156 for x. So as we say, the supplement of 156 is 24, or we can state that the supplement of 24 is 156 because they sum to 180. Two angles that sum to 180. I'm glad I can't still do that. Anyway, we'll erase this one again. And we'll go into the next one. And here again, angles 1 and 2 form a linear pair. They are called adjacent supplementary angles. Here we're looking at complementary angles, and we should put in our little right box here to allow us that that is 90 degrees. They do have 90 degrees. Notice how they shaded the arc in there. And if they showed that arc means it's 90 degrees. And we have 30 plus 60 equals 90. And again, that's angle addition when we are adding two adjacent angles to equal a larger angle. This is adjacent complementary angles. Next slide. Now we have a problem here. We should put in our right box angle. And so if we were to set this up, we notice that they are adjacent complementary angles. And the measure of angle 1 plus the measure of angle 2 should equal 90. And we substitute in measure of angle 1 is 2x plus 15 plus the measure of angle 2 is x equals 90. Then we get 3x plus 15 equals 90. We are going to subtract 15 from each side, and when we do that, I'll put it right up here. We get 3x equals 75, x equals 25. And we put it back in, we get this x to equal 25, and we put 25 into here. We get 2 times 25 is 50 plus 15. We do get, indeed, 65. So I'll circle those answers. 25 plus 65 does indeed make 90 degrees. Complementary angles, this was looking at an adjacent case. And we're going to probably, let's see what the next slide will look like after I have to learn erasing 101. This is a little frustrating here. I see this little circle, and that little circle isn't very big. Oh, getting it. There we go. Taking up that time, but here we go on to the next slide. Here we have non-adjacent complementary angles. You can see 31 plus 59 does indeed equal 90 degrees, showing you their non-adjacent angles. And here you can watch this video. If you go on my website, you can go to the Prezi presentation of this vertical and special angle presentation and watch another video regarding those types of angles. So once again, this is the video to my Prezi. If you want to watch the video within the video, please go and just watch the Prezi presentation and you will be able to watch the video. I hope this helps. Have a good day.